Hi, I am Tutor in Applas. Today we are going to discuss about Linux, high embedded Linux kernel and driver development part 2. Compiling and booting Linux, kernel source management tools. cscope, cscope source code.net tool to browse source code, mainly C, but also C++ or Java. Supports huge products like the Linux kernel. Takes less than 1 minute to index Linux 2.6.17 source pass. Can be used from a test like Div and Emacs. In Linux kernel sources, run it with cscope -rk, cman, cscope for details. Always searching code for all references to symbol, global definitions, functions called by function, functions calling a function, text string, regular expression pattern, a file including a file. This external this is scope screenshot is shown in figure. Kscope sourceforge.net, a graphical front end to cscope, makes it easy to browse and edit the Linux kernel sources. Can display a function called tree. Nice editing features, symbol completion, spelling checkers, automatic indentation, usage guidelines. Use the kernel setting to ignore standard includes. Make sure the project name does not contain blank characters. Kscope screenshot is shown here. The symbols in current file, main window, project file, query window. Kscope screenshot 2, various functions and their location. The text are shown in here. Called free function tree is depicted. LXR, Linux cross-reference source projects. LXR, generic source indexing tool and code browser, web-based, server-based, very easy and fast to use. Identifier or text search available. Very easy to find declaration, implementation, or user symbols. Support C++, supports huge code projects such as Linux kernel process 4MB in version 2.6.26. Takes some time and patience to set up configuration, indexing, and configuration. Linux indexing very slow to Linux 2.6.17. Several hours on the server with an AMD Sempron 2200 plus CPU. Using Kscope is the easiest and fastest solution for modified kernel sources. You don't need to set up LXR by yourself. You use our HTTP LXR PL server, other servers available on the internet. This makes LXR the simplest solution to browse standard kernel sources. LXR screenshot is showing cross-reference on Linux kernel user.c. Ketchup, easy access to kernel sources trees. Link Ketchup wiki makes it easy to get the latest version of the given kernel sources tree 2.4.6, 2.46, 2.6 minus RC, 2.6 minus Git, 2.6 minus M, 2.6 minus RT. Only downloads the needed patches, reverse patches when needed to apply a more recent patch. Also checks the signature of sources and patches. Ketchup example, get the version in the current Ketchup -M 2.6.10, upgrade to the latest stable version. Ketchup -G 2.6 minus step 2.6.10 to 2.6.12.5, applying patch 2.6.1 VZ2, applying patch -2.6.12 VZ2, applying patch 2.6.2.5 VZ2. You can get back to 2.6.8, Ketchup -G 2.6.8. More information on example usage link. The -G option of Ketchup disables sources segregated checking. See our kernel sources annex for details about enabling kernel sources integrity checking. Compiling and booting Linux kernel configuration. and defines what features to include in the kernel stored in the .config file at the root of the kernel process. Most useful commands to create this config file: make xconfig, gconfig, menu config, old config. To modify a kernel in the GNU Linux distribution, config files usually released in boot together with kernel images. Boot config 2.6.17 lemon generic. The configuration pane can also be found in the kernel itself. Zcat proc config gz if enabled in general setup kernel .config support. Make xconfig the most common configuring interface to kernel. Configure the kernel. Make sure you read introduction useful options. File browser easier to load configuration with. Use such interface to look for parameters. Require Debian Ubuntu packages and lib qt3 mt dev and g++. Make config xconfig screenshot. Code maturity levels option, general setup, system type are selected. Looks for a keyword in the description string allowed to select and unselect found parameters. ISO 9660 CD-ROM file systems are compiled as a module separate file. Config driver options are taken, then compiled statically into the kernel. Then section name helps to locate the setting in the interface. All parameters are prefixed with config. Make gconfig in new GTK based graphical configuration interface. Functionality similar to that of make xconfig, just lacking a search functionality. Required Debian package, the glade2 dev. Hence, color configuration is shown in here. Make menu config useful when no graphics are available. Permit into same interface found in other tools. PCBox build root. Require Debian package lib in cursors dev. Make old config needed very often, useful to upgrade the a.config file from an earlier kernel release. Issues warnings for obsolete symbols. Ask for values for symbols. If you edit a.config file by hand, it is strongly recommended to run make old config afterwards. Make all new config. Only set strongly recommended settings to Y. Set all other settings to N. And very useful in embedded systems to select only the minimum required set of features and drivers. Much more convenient than unselected hundreds of features one by one. Undoing configuration changes is a frequent problem. After changing several kernel configuration settings, your kernel no longer works. If you don't remember all the changes you made, you can get back to your previous configuration, cp config, old config. All the configuration interfaces of the kernel, xconfig, menu config, all no config. Keep this .config old backup copy. Make a list all available make targets, useful to get a reminder of to look for new or advanced options. Customizing the versions string to identify your kernel images with other built from the same sources but different configuration. Use the local version setting in general setup. Example, general server configuration local version Acme 1. The uname or in the Linux system will run 2.6.20 Acme 1. Compiling and booting Linux, compiling the Linux kernel. Compiling step, make install step, sudo make install, sudo make modules install. Compiling faster on multiprocessor OS. If you are using a workstation with n processor, you may roughly divide your compile time by n by comparing several files in parallel. Make a -jn run several targets in parallel whenever possible. Using make -j 2 or make -J3 on single process workstation. This does not take much. In theory, several parallel campaign jobs keep the processor busy, which other processors are waiting or fails to be written. In practice, you don't get any significant speed up, not more than 10% unless your IOs are very slow. Comparing faster with the Ccache, Samba.org, compiler cache for C and C++ already shipped for some distributions. Much faster when comparing the same file a second time. Very useful when .config file change are frequent. Use it by adding a Ccache prefix to the CC, host CC definition in Makefile. CC, Ccache, $cross compile GCC. Host CC, Ccache, DCC, performance benchmark 60% with Fedora Core 3 config file, many modules, 82% with an embedded Linux config file, much fewer modules. Kernel compiling tips: review the full GCC LDD command line, make a V=1, clean up generated files to force recompiling drivers, make clean, remove all generated files, caution all remove receiver .config file, make MR proper. Also remove edited backup and patch rejects files. May need to generate patches, make test clean. Generated files create when you run the make command, VM Linux, raw Linux kernel image, non-compressed. Arc boot is a image, default image on ARM, zlib compressed kernel image, arc boot B is a image, default image on i36. Also is zlib compressed kernel image, caution B is a big zip, but not big zip to compress. Big zip to compression support only available on i3 as a tactical patch, not very attractive for small embedded systems, though consumers 1 MB of RAM for decompression. File created by make install boot VM WinUEZ version, compressed kernel image, same as the one in arc boot. Boot system map version stores kernel symbol addresses, boot configuration, kernel configuration for this version. Lib modules version, kernel modules, processors, built everything needed to build more modules for this kernel, make file.config file, make symbol information module.sim version, make kernel headers, include ASM, kernel module.kbo, kernel object files, the same directory structure as in this source. Lib modules version continue. Modules modules aliases for module loading utilities. Example, aliases sound services --0, sound mixer OSS module, DEP module dependencies. See the loadable kernel module modules for section. Module symbols tell which module a given symbol belong to. All the files in the directory or text files. Don't hesitate to have a look by yourself. Make config, make comparing the kernel in action, make config, make sudo, make install, make sudo, make modules install. Comparing and booting Linux device files. Character device files access through a sequential flow of individual characters. Character devices can be identified with C type, ls-l, C at the beginning. Example devices: keyboard, mice, parallel port, IRDA, Bluetooth port, consoles, terminal, sound, video, etc. Block devices files access to the block data of blocks of a given size. Blocks can be accessed in any order. Blocks devices can be identified by the B type, ls-l in a B type. Example devices are order floppy disk, RAM disk, group devices. The device had major and minor numbers. As you could see in the previous example, device files have two numbers associated with them. First number, major number, second number, minor number. Major and minor numbers are used by the kernel to bind a driver to the device file. Device file names don't matter to the kernel to find out which device driver a device file corresponds to, or when the device name is to cryptic C documentation devices.txt. Device file creation. Device files are not created when a driver is loaded. They have to be created in advance. sudo make nod dev device C/B 5B major minor. Example, sudo make node device TTY0 C4 64. sudo make node device HTA1 B31. Thank you.